Hello, this is the first part of Lab 4 for FED 101, and the first part deals with the analysis of circuitry containing diodes and LEDs. In this case, the diode is a semiconductor device that will allow the current to flow in one direction only. And here we're going to show that in the direction set through this circuit, a light bulb would light up, because that's for you a visual way. But you will also see that theoretically I'm using a resistor in this case as far as the circuit is concerned for the simulation. That's only for multisim, to show an equivalent of what's happening in the circuit, in the sense that the same current will flow. That means the light bulb acts like a 39 ohm resistor. I will also show that the voltage drop across the diode, in this case it's a general purpose diode, 1N4001, will be about 0.7 volt or so. It'll be a little bit higher, but you will see that in many classes, especially when the power supplies that are involved are very large, 0.65, 0.7, 0.8 volts, up to some amount like 0.8 volts, for example, for general purpose, would be considered to be just like a constant, and we use usually 0.7, right? Unless, of course, you want to do very detailed and accurate calculations. But in this case, we will assume that the voltage drop when it conducts will be 0.7 volts, regardless. Theoretically, of course, I mean, in this case, I mean, there's an approximation, regardless of what's connected to it, which means that if you use KVL, based on the fact that we're using a 5-volt power supply, that means the voltage drop across the resistor, regardless of its value, assuming that, of course, the voltage drop across the diode does not change that much, will be about 4.3 volts, more or less. So this is what we're going to try to show through the measurements, and let's see what happens. Again, I provided a 5-volt power supply through an external power supply in the voltage regulator, the 7805. The positive of the power supply, which is the red lines in this case, are connected to the anode of the diode. The cathode, and if you see, let's see here if we have, you see there's a silver ring at the end here. Usually there is always a ring, silver, black, whatever. That ring represents the cathode, right? So in this case, the cathode is supposed to be connected to the light bulb, but in this case, I'm providing an open circuit here with two wires standing. When I connect them, that provides a short circuit, which means the cathode is going to be connected to the light bulb. But when I don't connect them, I'm just using that open circuit there to insert the ammeter when I intend to measure the current. So for the time being, as I short circuit them, in this case, if I short circuit them, and that means the current should flow, and in this case, assuming that I can get the wires to stick to this breadboard, okay. Hello, and of course the rookie mistake that I made was the fact that because I need my my desk, and so sometimes I disconnect the power and I forget to connect it again. So as you see here, the light bulb lights up, which means the current is flowing through the circuit. And that will happen only when the anode has a higher potential than the cathode, and of course in this case about 0.7 volts or so, right? So if I disconnect these two wires and I insert the ammeter and I set it for current measurement, and we will see here that the current is about 110 milliamps or so, 111 or so. So as you see from the multisim simulation, which reads about 108.6 or so, because I used the 39 ohm. Of course, if I wanted to, I could have been more accurate. But here the point is that just to show that there is a current flow. Of course, with the resistor, you can only see a current flow. Here with the light bulb, we don't need to really measure the current. As long as we can see the light, we know that the current is flowing. And if you the voltage now, if I want to, I'm just gonna put a short circuit here. Just to be able to measure the voltages, and in this case, just to show that the voltage across the diode is about 0.78 volts or so, right? Obviously, from KVL point of view, you can see that if this 0.78, that means it's about 4.22 volts or so across the light bulb, right? And obviously, you saw from the simulation that the voltage is about 4.24 or something, right? Of course, in this case, the variations are due to the fact that the power supplies that I use may be a little bit higher, like 5.02 or 5.2 volts or something. I think 5.02. So obviously the point here is that we have verified that if the diode is connected this way, the current will flow. And you will see that if I reverse the diode direction, right, that means I reverse the pins, I connect the cathode to the power supply, the positive of the power supply, and the anode to the light bulb, and you see here there is no light there, that means there is no current that flows. And if I want to measure the current, you will see that it is 0. So the point here is that, and of course in this case is because the cathode has a higher potential than the anode, and of course the current will not be allowed to flow. It's what we call reverse biased, right? So this is what happens when a diode is involved in a circuit. It's a nonlinear device. In this part of the diode analysis, we are also going to be practicing with an LED, a light emitting diode. So it is similar to the diode in the sense that the current will flow only in one direction, but the difference is that now the diode itself would emit a light when a current goes through it. And so in this case, again, it's almost the same setup as before. We have the power supply that is connected to the anode, and the cathode in this case is connected to a resistor which is connected to the negative of the power supply. In the case of LED, you will find out that usually if it is new and you haven't tampered with the terminals, that the longer wire is the anode and the shorter wire is the cathode, right? Or you can also see that if somebody tampered with the terminals, then you can see that the cathode also has a flat side. If you touch it, you will see it's not circular, it's flat. That's the cathode, we know. So as I connect this resistor to complete the circuit to the negative of the power supply, as you see here, that the LED would light up because the current is flowing through it. And now again, if I reverse the leads of the LED, as you see here, the current cannot flow from cathode to anode, and that's why it does not light up. And if I want to measure the voltages involved, in this case, let me put it back in a forward direction. So in this case, it's about 1.8 volts. Obviously, it's a lot higher than the general purpose diodes, right? Which in our case was a silicon diode. That's why you expect somewhere around 0.7 volts or so. But again, it's the same idea, that in the sense that the current will be allowed to flow only in one direction.